So in the last video we actually met, without mentioning it really, the multiplication rule. Okay, so with the probability of one event and another, to find that probability, that's equal to the probability of one multiplied by the probability of the other. Okay, so it's the multiplication rule that we use in probability. Anyway, so we can, let's say we toss a coin and we throw a dice. So to find the probability of getting a head and a 4 is equal to the probability of the head multiplied by the probability of the 4. The probability of getting a head is a 1 and 2, a 4 is a 1 and 6. So the probability of getting a head and a 4 is 1 in 2 times 1 and 6 is 1 and 12. And that's kind of the faster mathematical way of finding the answer, which prior to this in junior cycle we used the sample space, and we found that to find a head and a 4, there's only one of them, 1 in 12. So we've done it via the sample space here or mathematically here. And so now we'll talk about Bernoulli trials. A Bernoulli trial is an experiment consisting of repeated trials where the number of outcomes and their probabilities does not change, and each trial outcome is independent of other trials. So by example then, a coin is tossed until a head occurs. Find the probability that the first head occurs on the third toss. Okay, so we're looking for the probability that we get a tails and tails and head. Probability of tails and tails and head. So how do we work that out? Well, we kind of know now from where we see and, that means we multiply the probability of the tails by the probability of tails by the probability of heads. So it's a half by half by half, it's a 1 in 8 chance. A dice is rolled. Find the probability that a 5 or 6 appears on the third throw. What we're looking for really is the probability of, on the first throw, not a 5 or a 6, and on the second throw, not a 5 or a 6, and on the third throw, a 5 or a 6. So the probability of not getting a 5 or a 6, in other words, getting a 1, 2, 3, or 4, is 4 and 6 is 2 over 3. And the probability when we throw a dice of getting a 5 or a 6 is 2 and 6, or 1 over 3. So the probability of not getting a 5 or 6 on the first throw, and not getting a 5 or 6 on the second throw, and getting a 5 or 6 on the third throw is 2/3 by 2/3 by 1/3 is 4 in 27. A ball is dropped into this device here, and it can exit in one of the 4 ways, A, B, C, or D. Find the probability that the ball will exit through A. Well, there's 1 in 4 chance, so it's 1 in 4. Find the probability that it will exit through A or C. Now this is mutually exclusive, as it can't exit the 2 holes at the same time, so it can't go through both. So it's mutually exclusive. So the probability of it going through A or C is found by adding the probability of A to the probability of it going through C. Sorry, there should be a C there. Okay, so that's 1 in 4 plus 1 in 4 is 2 in 4 is 1 in 2. Okay. Now, what about finding the probability that if 2 balls are dropped in a row, that they will both exit through A? Well, that's equal to the probability of A and A. Now, we know we see the and sign, that means it's the probability of it going through A multiplied by the probability of going through A. So that's 1 in 4 times 1 in 4 is 1 in 16. Okay. And what if we're asked to find the probability of 2 balls being thrown in, both shooting out through A or both shooting out through C? Well, we've or here, so that means we add. So we look for the probability of them both going out through A, which we found here is 1 in 16, plus the probability of them both going out through C, which is 1 in 16 as well, if we were to go through this again. So it's 1 in 16 plus 1 in 16, it's 1 in 8. So now we're going to look at this notion of expected value. We have a spinner here, and the spinner or circle is divided into 6 equal sectors. You pay €8 to spin, and you win the amount in the sector. What is the expected amount you can win or lose in this game? And the way we do this is we look at the different payouts with 0, 6, 12, and 15. We find each of their probabilities of happening. So To get, if you spun this, the chances of getting a 0 are 2 in 6, okay, and the chance of getting the 6 are 2 in 6 as well. A 12 is only one of those, so it's 1 in 6. The probability of getting a 15 is 1 in 6. We then multiply the payout by the probability, and we call this x by px. X by px. So this should be x there. So that would be 0 here. It's €2 here, €2 here, and €2.50 there. And the expected payout is actually the sum, sigma x dot p of x. So it's the sum of these guys, and that's equal to €6.50. So the expected payout is equal to €6.50, or the expected value. Now, if you were to pay €8 to play the game, the expected payout is £6.50 minus 8. It's actually minus €1.50. So you can expect to lose €1.50 if you continue to play this game. And we'll just finish by saying that statisticians and mathematicians have found that by using this method to calculate the expected value, that the more the game is played, the more likely the expected value is to be as calculated with this formula. Okay.